Awesome. Yeah. Good afternoon, guys. Welcome back to TMMI's TestFormation 2026. Uh, Track 1. I'll be your host. My name is Sukir Shivkumar, and I work for International as a QA automation tester. For this session, we have Dr. Michael Bar-Sinai. Welcome, Doctor. Uh, Let me give you a quick introduction. Uh, he's a software engineering by training, but he also has a mid-career PhD in formal methods and requirement modeling. He's created various software and software qualities since about 1998. They include production systems, online information systems, libraries, open source tools, etc. Fun fact: he's also a former data science toolsmith at Harvard's IQSS and is currently the CTO and co-founder of Provengo, a startup crafting model-driven software engineering tools. Yeah, the floor is yours, Michael. Thank you so much.
Oh, thank you very much, Sukir, and thank you all for coming. Let's talk about model-based software, model-based testing, and how it can help us, handle the challenges of software engineering and software quality, and with all the AI stuff involved. So assuming everyone sees my screen, complain if not. Okay, so already talked about me, so you'll gladly skip this because it's always somewhat embarrassing. Talk about yourself. I also bake, but I added something like bacon fermenting stuff, which is always nice to have after a good day. Anyway, today, what we're going to talk about today is, first of all, where we're at, right, in terms of software quality with all the AI stuff going on. I'm going to take a break a bit and ask what is model-based testing. What does it, it's, the technique has been there for a while, but it's not, didn't really make it to the mainstream. So we'll do some short introduction there, and then we'll see how it can help us do our current QA roles, but in the new setting of AI. And then we can see how it's going to expand. I can expand what we do and make basically QA more central to the software development lifecycle. And finally, we're going to wrap up, get some Q&A, etc. So where are we currently in this whole software AI revolution? So not in a very good place. I mean, everything's moving faster. And this, I had all kind of, like, I keep them. I keep all kind of, publications about errors and cases that had, and I had quite a few slides about examples. But then yesterday, which I'm sure you all heard, Amazon dropped a little bomb saying that they're no longer allowing, basically halting direct AI generated code from getting to production. And what they basically say, if you look at this up, this is from Financial Times, that the issues were basically there's a trend of incidents about high blast, what they call high blast radius of Gen AI assisted changes. And basically what they're saying is that the safeguards are currently not yet established. So basically we're running a lot faster, right? As development organizations that develop software. So it kind of like looks like this, right? So we're moving much faster, but we lost the steering a bit. So, I mean, this is happening to Amazon publicly, but I guess every one of us has been in an organization that it's either happening or is about to happen, that we need to understand, okay, now development moves very fast, product moves very fast. We need to keep up, but make sure that everyone are, clients still get quality product at the end. And it's up to the QA basically to make sure that things work. So let's look at the map of application, right? Application release. Let's say that this is the island, right? And what the customer intended or something. And this is the peak of perfection, right? This is where we want the released application to be. But there's a lot of monsters around, right? We can there's downtime and security issues and regulations, privacy, a lot of things that can go wrong. And now that we have a release candidate of application, we need to ask ourselves, where is the release candidate in this map, right? Is it safe to release, right? Because QA really is not just about finding specific bugs. It's about understanding the risk in releasing the software and making sure that the clients or that the organization, everybody are happy with what goes out and blocking it if it's not happening, right? So we have this release candidate, and is it suffering from security issues, right? Is it suffering from regulation problems? Which is one of the that's a generally nightmare scenario if you're in a working in a regulated market and you release some version, it works fine, really good for like 2-3 months, and then one evening the CEO gets a call from some regulator saying, well, for the last 3 months your application's been violating this regulation thingy, and we're not happy, and pay us this amount of money or like get shut down. So sometimes you actually wish the application would have crashed, right? So there are many things that can happen, right? Maybe the application is just not good enough. It's not, just flaky and things doesn't work well. Or maybe it's good enough. And the question really is, where are we at, right? So it's really a tool problem. When we need to release, we really want to know how far are we from the perfect behavior. But what our QA tools normally tells us is just, did all tests pass? And that's a start, but there's an underlying assumption there. And the underlying assumption is that the tests with results somehow reflect the requirements, which somehow reflect what the client intended, because that's another thing that can go wrong, right? I mean, there's a lot of communication involved. There's a lot of what I understand from what the product said, and the product understand what the client said, and there's a lot of communication. The good news is that this arrow here between test with results and the release candidate is mostly solved, right? So unless your CI is a bit of a mess, then you know what are the test results of the release candidate. But the rest is just requires manual validation, basically, meeting, detecting misalignments, all kind of production failures, prompt and pray, which is apparently a new way of working with the LLM. So there's a lot to improve here. But it's all about really, the issue is that the intent is vague, right? And it's hard to work with it. So the idea of model-based testing is really to focus on the intent, right? And so we do something along this line, right? So first of all, we added another factor here, which is a deterministic model, or it doesn't have to be fully deterministic, but it's something that's analyzable. It's formally understand what it is. This is not. It's very different from an AI model, which is something that's very creative and has a lot of power, but can also mistake and hallucinate and is very vague. So this is a more traditional formal model where you can actually analyze and communicate it. So the bad news is that we added another layer. The good news is that basically all these lines now are practically solved, and we're going to see this. So we can take from the model, we can automatically generate test suites. So this is solved, and because we can analyze the model and sample it and have basically the client kind of like experience what the model, what the intent means, or what we understood from their intention, we can actually pretty much solve the whole does the model correctly reflect the intentions, and is the requirement complies with the model. We can get all this product side of things pretty much solved as well. So this is the traditional realm of QA, right? Getting the product and making sure that it works, and analyzing how risky it is to send it out. And we're going to look at how model-based work testing help us do this work easier and better. But we're also going to look at this area, right, the product area, where basically we can expand the role of QA, also shift left all the way to the product and even the client in some cases. So I mean, given if you're not living under a stone in the last the last year, the question is why can't we just use AI, right? I mean, we introduce a new model thing and all kind of formal methodologies and stuff. Can't we just use AI? So first of all, let's be somewhat accurate about this. It's not really AI, right? There's no intelligence per se there. It's basically LLM and the transformers, right? So when we strip away the marketing, we can ask ourselves, okay, can LLMs and transformers and maybe some additions get everything right? And the answer is no, or at least not yet. This is just from a short searching of people who search this, and just find. But you can find a lot of pieces about this. Basically, AI is not enough, right? And the reason is that it's basically a glorified autocomplete, right? So it doesn't have a mental model of what should happen. And it's just trying to take the requirements or whatever you gave it and the context, and then guess the tests in something that makes sense, but there's no understanding there. And this is what we're trying to do, right? What we will do here is basically let the AI develop a model for us, a deterministic model for us, and that model is something we can inspect, understand, validate that is correct, and then takes the tests from there, right? If you ever played with automatic automatic test generation like this, you might have had this happen to you, right? So you tell Claude Code or something, it's very important, test will pass, and says, okay, well, we can solve this. I'm just going to add assert true. And this is something that, I mean, you see what, hopefully we'll see less of it, right? I mean, it's something that's relatively easy to validate, but just because the test became green doesn't mean that you get an information about whether the application is ready, right? We can also have a lot of empty tests that look good on the report. Okay, so with that, what model-based testing promises us is quite a few things, right? First of all, we're going to generate test scenarios, create test suite composition, because it's not just about a single test, right? It's a whole test suite about it. We can know what is the actual functional coverage, and add a lot of metadata automatically to the test. So we can, if we have to do drill down or understanding what happened or what went wrong, it would be easy. We can avoid over testing. That's another thing, right? I mean, if sometimes you say, okay, I have 1,000 tests, okay, but could you prove the same points with 100 tests? Because then you could save 900 tests, 900 executions per release, right? So we need to test just enough, but correctly. And then there's the whole thing of once you automatically generate test suite, everything becomes way more agile, right? Because you don't have tests are no longer a legacy code that you need to maintain, but you just throw them away and regenerate them. So there's a lot to like here, if we can deliver, obviously. But to summarize, it's basically the idea that QA would deliver more value faster and earlier in the software development lifecycle, which is presumably a good thing. And by value, talking again about reliability and risk assessment, release confidence, this kind of thing, through or the fact that we know what we're testing and we know how tight we're testing it. The idea itself, by the way, is not very new. And so this is from 1997. By the way, I think the first or one of the earliest ones. This is a testing, a system called TestMaster, wasn't really released outside of Teradyne. And the idea is that you would draw a state machine, basically, of the tests, right? So this is a telephone system, basically a switch box, digital switch box, and people can start a call, put it on hold, hang up, do a call, kind of follow me, all kind of these things. And it's very easy to create a lot of tests here. So here's, for example, one test, right? User goes in, what do you have? A calling coordination and marking a call urgent and stuff, and eventually hangs up. Okay, so this is any running around through this machine is basically a valid test. Some of the tests, by the way, I mean, there's an infinite amount of tests here, interestingly enough, because you don't have to go to hang up. You can always run between cases, between states, and it's surprisingly useful. I'm sure some of you guys had to check for, say, memory leaks or resource consumption or these kind of things. And in these cases, what you would do is basically create and not technically infinite, but like a test that would run for 2 days, and you'd monitor the resources. So this is very nice, and it's also a very good way to communicate with the rest of the team about your test plan, right? You can just show this to even to non-technical people, right? A product guy, non-technical product guy could look at this and understand what's about to be tested and give you valuable information about, are you testing the right thing? Are you missing anything? Is, maybe some test there or some state there is not useful anymore. The bad news is that it doesn't really scale. And the good news is that AI can help with this, and we'll see, but just drawing things doesn't really scale fast enough. This is 1997, right? 2026, what we normally do today is we use a lot of different type of languages, sometimes code, sometimes visual languages, sometimes just, tables, and of course, chats. And code generation, take everything in and then have the computer generate this kind of test plan for us. This specifically here is the test plan for our system, but again, there are a few tools, and I'll provide links later. But this is what we test before each release. So let's look at an example PRD, since we're good on time. I'm going to look at something I think would familiar for most of us. Somewhat silly example of a morning routine of a kid, just so that we don't go specific like UI testing on whatever. So here's the PRD, right? As a kid going to kindergarten, I need to wake up, wear clothes or shirt, pants, socks, shoes, etc., brush teeth, tidy up, and go out. Okay, that's a PRD. We can feed this to vibe code this or just write the code here. Not very complex, and we get something like this. I'm not going to get into the weeds of it, but the important thing to note is that we never said about the order in which the clothes must be worn. So we need to model all possible orderings, right? Because there's no specific path here. This is, by the way, currently just happy path. We can add rainy day tests, etc. This compiles to this type of test space, if you will, right? So there's a lot of test scenarios defined there. Here's one test scenario. Here's another test scenario. We can basically create a lot of tests just by having this, I don't know, 12 lines of code or something, which are, again, something that you can vibe code completely. But because we can visualize this and verify this and show this to and create sample scenarios, this is something we can take to even to non-technical people and say, okay, this is what you intended to do, right? This is what I'm about to test. Is this okay? And people, in my experience, this is the first time you give value to the rest of the team as a QA, because I've seen meetings where someone would say, like, this error there doesn't make sense. And then we trace it back and see that the requirements actually kind of ambiguous in that case. So it was like everybody were right, but could understand this in different ways. Once we have this, we can throw in automation. You can do this either by embedding it on the tool or by post-processing. It's technical and very different tools do it different ways. But the thing is, once you have this in place, you can actually run the thing. And if you have like a morning simulator, you can actually run and automate it. I mean, this one is UI, but you can do similar things with APIs if you want. So we basically got from description of the code, right, and validated description to actual running tests. And we can, for example, if we want to slightly elaborate this, here we are adding breakfast options, right, just to make it a bit bigger. So we get this kind of test space, right? So we can now talk about not just a single test or several test scenarios that we try to make it cover everything. We can now talk about all possible tests in this that are implied by some scenario or by some description. And once we have all this, what we can do is we can ask the computer to create an optimized test suite, right? So here, for example, we told the system to generate, we want to cover different type of breakfast, right? Maybe we want to have a healthy breakfast and sometimes skip breakfast. And we want to a test suite of size of 5. So can you create a test suite, a minimal test suite size of 5 that covers all these issues? And turns out you can. This is automatically generated. B, done very fast. It takes seconds. And it's, again, something you can take it to the team. So this is what we're about to test. All the test readiness reviews become much more interactive now, right? If we can take the same test space and say, okay, suppose I think there's an issue when we test when we wear the shirt last. Let's create a test suite that covers that, right? So again, we can do this. We don't really care about the breakfast here, which is on the right side. All that we care about is the fact that the last thing we do is wear a shirt. And again, it's something that's very easy to do. So we can create the tests as we want. Once the tests are generated and executed, because they're generated by a computer with all the metadata, and we know why the tests are there, in a sense, or what are we testing, it's very easy to generate all the metadata, like names, and we can and things that happen, or kind of like tagging, and certain goals that are covered. And for each action, you can actually automatically know what is happening or why this action was taken. So all the documentation of what we're doing, of the testing and the test suite composition is much more easier and robust to do. AI is a great help in this case, because if you want to generate more test models using AI, then it's easy to do, because all in all, it's just normal vibe coding. But the result of this is a model that you can analyze and visualize and verify and understand what's going on. So it's not a prompt and pray. It's basically working together with AI in generating a model that could generate tests that you know are correct. And we actually played a bit with this in various techniques. This is an upcoming publication we're going to have about a testing we did with some e-commerce platform, which I'm not saying the name yet, but pretty popular one. And there's a concurrency issue there, where if you play a bit with the ordering, you may and change currencies, you may expose some bug. And we're able to create basically a space of a lot of tests there, again using a combination of vibe coding and manual coding. And then use machine learning techniques to kind of like tease out this type of bug and find a lot of bugs there. Open APIs are another cool way of starting a test, where you can just take an open API if it has a lot of good English documentation, right? Or natural language documentation of what each API endpoint does. You can actually take this, feed it to an LLM, and generate a test suite that creates automation, API automation, but does this not just by your normal taking an endpoint and just playing with the input, but rather doing semantic kind of plays, right? So if it's about, I mean, our test was about a library loaning, book loan system. So you can add a book to the library, and then order it and cancel it, and this all flow of the actual business level flows are something that you can take and generate pretty much fully automatically, just by with a few prompts. Okay, so this was the traditional realm of QA, right? Creating the testing, but I want to also look a bit about where model-based testing can take us even more left, this left, more towards that, and to do this, let's get back to the kindergarten for a second. And so suppose one day you come home, and your kids come home and has this letter from the teacher telling you that there's some terms and conditions and disclaimers in the kindergarten now, and under no circumstances, except for when explicitly instructed to by the kindergarten teacher, blah blah, childlike or child. So you look at this and say, I don't know what's going on here, but I have a friend who's a lawyer. Give it to a friend, and the lawyer says, well, you know what it really means is, don't send your kids with socks over their shoes, because that's against kindergarten regulations. Okay, so it's a weird thing to do, but the question is, did we even allow this? And in order to do this, we just basically encode this kind of requirement into the testing model. Okay, so again, we can skip the technicalities, but the idea is that basically we just wait for shoes to be worn, then wait for socks, and then we say, no, this whole test scenario is making no sense. If we add this to the model, turns out that we actually allowed this kind of bad scenarios, and this was part of the testing suite that we just did. And not only do we have this marked, right? We know there are 4 cases here where this happens. We can also find the trace, right? Find how to get to this kind of breach, right? So I mean, this is kindergarten stuff. Suppose you're doing a banking application, right? And then you're under know your client kind of requirements, right? So you cannot transfer money to someone that wasn't verified. So this is the type of regulation that you can find and can protect against breaching, right? There's an event of money transfer, but there wasn't any verification step before that, and this means that this regulation is breached. And it's something that, by the way, you can look at this. There's no, I removed the automation parts here, right? We don't need automation. In fact, even looking at this slightly closer, whose bug is this, right? And if you look at this, oh, okay, now I see that we have questions. Okay, so thanks, Krishna. I'll answer. That's a good question. But let's finish this slide. So whose bug is this, right? So the question, this is right. This is really a problem in the requirements. Right? This is a bug because the product guy didn't tell us any orders. Just wear the clothes, socks, shoes, pants, and shirt. There wasn't any ordering involved, and so we allowed it, right? So this type of thing is basically the QA telling the product that they're breaching legal, right? And there's no developers involved here at all. There's no automation, there's nothing. It's just requirements over the requirements. And so this brings us basically to this idea, right? So with all this Gen AI and model-based testing and SDLs, software development lifecycles, and either TLAs, which is the acronym for three-letter acronyms. Now I realize that SDLC is like a four-letter acronym, but that's why you need to QA your slides, I guess. So if this is the traditional SDLC, right, we start with the customer as their idea, and they're talking to the product generates all kind of documentation, and then goes to development and QA, and we basically have this kind of like feedback loop, and eventually we're ready to release and the system release, right? That's the traditional QA, and we try to shift left, right? So the product try to keep everyone in like in the same, the same page, and maybe we let the developers do some QA and try to do things earlier. But basically, this is like the classics. Now, what we can do is get some early feedback loops. Basically, we start with the same thing. The customer has their intention. They talk to the product try to formalize this and then make sure that everything's fine. And then the product actually goes to the QA, and QA creates the test model. So this is basically describing the external behavior of the system. This is the first time the system would get you get like a deterministic computational thingy that describes what the client wants, and but there's no implementation yet, right? So we can check for bugs that, like we saw 2 slides ago, where we can have kind of breaches or anything. We can visualize it, show it to the client, show it to the product, make sure that everyone on the same page. And once we're there, we can start prompting or creating. It's basically just making sure the specification is correct, right? Once the specification is fine, we can do a combination of vibe coding or traditional development or anything in somewhere in the middle, and get something software that we can actually test. Then we can do traditional testing. Again, this time we don't have to manually write the test. We can generate them from the test scenario, from the testing model. So easier for us. We basically just need to add automation. And then once we're happy, we're ready to release. So this is like where we can take it. I have seen something like this happen with one client of ours, where the QA basically was basically it wasn't official, right? Nobody said large enterprise company, and they didn't do anything official in changing the way they develop software. But it was basically, yeah, let's talk to QA first. So this can happen, right? I've seen this happening sometimes. And that's basically the idea. So this brings us to the question of when to not do model-based testing, which is equally important. So first of all, something just can't be modeled, right? Especially exploratory testing, this kind of thing, just playing with the application. Model-based testing is mostly about what should happen and then validating that it's happening. If you didn't model it, you don't know that it's going to happen, right? So exploratory testing is not something that could be easily replaced. Okay, for organizational resistance to change, a lot of times for just, we never done this kind of thing, let's not do it. I think this kind of changes now with the AI and the fact that everything moves, so maybe it's a good time to try new techniques. Sometimes the model you need, the general thing of learning curves and these kind of things. Gen actually helps a lot in this because it's very easy to code models. Models are, because they're by definition simpler than the application, right? They're just describe the documentation. We kind of like gloss over all the implementation details. It's very easy. It's a black box description. So GenAI has not only easy time doing this, and it's very easy to understand what's happening because you can visualize, verify. Again, depends on the tool. So again, this is basically trying to be respectful of the time here. This is basically a proper use of AI in the sense that instead of getting opaque results, right? I mean, we basically, as a QA, we have one job, which is suspect computer output, right? So going to a LLM plus transformer saying, here's the requirement, give me good tests. It's kind of like, okay, but how do you know that tests are good? Maybe the tests are good, maybe it's perfect, but we need to know that it's perfect, right? And this is something that we need some more help with, and basically this is what modeling, formal modeling gives us, right? So instead of asking the LLM to create tests, we work with the LLM to generate a model that would create tests that we know that are good and we know are covering correct things. Okay, so where to go next? So first of all, there's a few open source tools like GraphWalker, and Intel had something called FMBT. They're available on GitHub. NASA has something called Java Pathfinder. That's a heavyweight one. Also only for Java, but this is like the hallmark of some part of testing. This is like actual formal verification. There's us. You can download and play with the tool. It's free for evaluation and for open source. And there's a lot of documentations you can see are probably this in the notes. BrowserStack has a good write-up about this. We try to publish information about this. And basically just look for formal methods or model-based testing or model-based software engineering. There's a lot of good things out there. Okay, so thank you, first of all. And one question that Krishna asked said it looks like model-based testing.
I'm so sorry to interrupt, Michael, but I think we're like 8 minutes or 9 minutes over time.
Okay.
So I'm gonna ask Krishna to like reach out to you personally, but this was super informative. So thank you so much. So
Okay. Thank you very much.
yep. Thank you. Thank you.
Mm. Mm.